Okay, so the next one that I'm going to talk about is rockets, and there's a lot of things that you could do with rockets and a lot of data that you can collect, and looking at parabolas and projectile motion. This one here, this water rocket, it's a very fun one. It's a very easy one for the kids to do and collect data on it. I do it with some of my very low math kids, and even they can run the numbers. So this is we usually do this one with just a right angle tree. And so what I have the students do on this is we just launch the rocket straight up. They do use a clinometer or something to get the angle. And so what they'll do is they'll launch the rocket up and use their clinometer to determine what angle the maximum is before it starts to drop. Now what we'll do is everybody will stand exactly the same distance from the bottle. So maybe you can pick whatever distance you want. Usually we'll do like 20 feet or so because that gives them a good angle. And so your base would be 20 feet, your height would be the height of the rocket, and then your angle would be whatever they can read. And then of course they'll be using opposite over adjacent, the tangent and the angle to find the height of the rocket. And so it works pretty good. So it's a really easy tangent problem to do on that. If you want to make your own little rocket here, I've seen this done several different times, and this one I would do it more in a classroom or hallway or something where there's grids on the wall in which they each make their rocket, and I would video it. Again, I love using their phones and slow motion on that and have them make it, and then they'll launch their rocket and video it, and then they can actually find points along to make the quadratic of what their rocket looked like on that. You could do several other things with it. This one here, you could do even, because you have to pressure this up. You can just buy off of Amazon the little pressure thing that does water rockets on that. You could do a volume and pressure and compare it to the height. So maybe we want to keep the pressure the same and vary the volume, and do your graph. So you could do your volume over height or height over volume, whichever way you wanted to do it, and then look at the graph and analyze it. You could keep the volume the same and change the pressure that you put on the bottle, and again with the height. So there's a lot of different graphing things that you could do with that. If you get on into the trig and stuff, you could probably launch this at different angles and start looking at that. So again, a lot of different things that you could do with your bottle rockets that makes it fun. Okay, this is another activity that I find very, very easy. So this could really be done with anyone with just very basic algebra skills. So this doesn't have to be a very high level course on there, but if you're wanting some graphing of data. Now, if you want to go on into higher levels where you're talking about inverse and direct variation problems, then you could also do this. And so it's very easy. Buy you a Fizz Keeper. You can get those off of Amazon. You can get them at Walmart usually. This is a fishing aquarium. That's what I'm looking for. Aquarium thermometer. On that, again, this is just a 2-liter pop bottle, but I also use the liter pop bottles. Really, you can use about any size that you want. And then this is just a syringe, usually even if you can order those online, or if you go to a pharmacy or something, you could have them donate some syringes. And then what I do is I melt the tip of it here. Okay, so take your plug out, take out the inside, and melt this, and then put it back in there. So here's what happens on this one. I do put the Fizz Keeper on the pop bottle, put the thermometer. I put it inside. I've seen people who put it on the outside, but I just throw it inside on that. And then you pump up. So I have the kids do a T-table with the number of pumps as my X and the temperature as my Y on that. And so we talk about the fact that the number of pumps is actually the pressure. And so when they graph it, they could do pressure. So they could call it pumps and then put pressure out beside it. And so I do, of course, an initial reading, and then we do 20 pumps, and then 40 pumps, and then 60 pumps, and then usually about 80 pumps. I don't get them too high. They can start filling the bottle when it gets really tight. Also be sure, safety, have them be sure they hang on to the Fizz Keeper as they let the pressure off. Don't let, because if not, it could shoot across the room. I do exactly the same thing with volume. Okay, and so what they'll see, of course, is as they increase the pressure, the temperature will go up on that, and then on this one, as they increase the pressure, the volume will go down on the syringe, and so you've got an inverse and a direct variation. And then again, if you want to tie that into your gas loss, you can do that also. So again, it's a very fun, easy data collection lab. This is another one. Again, it's very easy to do, but all you have to do is get a spring scale. You can buy, again, those cheap off of Amazon, or contact your science department. I'm sure they have one. Be sure it's zeroed out, and then all you do is hang different things from it. They can hang just things out of the classroom from it. Of course, they don't want to go over it, whatever, but you can read the newtons and the grams, and just read across and graph it, and then they'll find out that it's actually gravity. 9.8 should be their slope. So it's a very easy, they just read it on both sides. Okay, make sure they do read it in the correct, or graph it in the correct order, so that they get the 9.8, not 1 over 9.8. Another one, again, is just centimeters versus inches. Just do get your meter stick and have them just do a T-table with centimeters and inches as their X and their Y. And again, 2.54 centimeters per inch. So they want their centimeters on their Y-axis and their inches on their X-axis. And again, just have them measure about 10 different things in the classroom. Put their data together. If you want more data, then what I always have the kids do is, everybody do, maybe if you don't want to take as much time, have everybody do 5 and put them on the board, and then they just share. So you can do it different ways, but that, or I just have each one do 10 and then find the line of best fit. And then again, they're relating it to science concepts that they may not know that they knew. This is a geometry one, geometry construction. So if you do a lot with construction, again, if you look up geometry construction projects, this I pulled off of the internet. You can see the kids' paper over here, all the different shapes, and then they have to be able to use construction to recreate that shape. And so if you've talked about all the different types of construction, then they should be able to figure out, okay, I need to, draw, inscribe a triangle. I need to inscribe a circle inside a triangle. I need to inscribe a triangle inside of a circle. So you've got all those different concepts. And that's just some more. And construction. Okay. This was one of my favorite geometry, again, construction, engineering, design pieces. And what I did with these, this is when you're talking about nets and surface area and 3D shapes. Again, measurement, volume, all that kind of stuff. What I gave them, so in this case, you can see these kids have, and I just rummaged the storage closet to find things. So this one has paperclip boxes, and I think this one has 9 in it. I'm not going to swear to it, and then tape boxes. I did things like ping pong balls, marbles, glue sticks, batteries, basically anything that I could find. And the key was I tried to put, when I organized it for not numbers they would normally find. Gatorade bottles, pop bottles, that kind of stuff. So instead of having a 12 or 24 case, I made them have an 18 case maybe on that. And what they had to do was they had to actually draw out the net for the box, and they had to make sure that there was a 1/2 inch overlap wherever they wanted to glue. So you can see this is an example. So this person, when this folded up, this inch or 1/2 inch here would fold and attach here. So they couldn't have like 2 1/2 inches. So like a 1/2 inch here and a 1/2 inch here. It had to be an individual 1/2 inch. Okay, this one here's on the top. And so again, that it folded up and put it all together as a net. So again, it was a fun project. Here's the key to it when they did this. So I only gave them one box. So I would give them one box of paper clips. I would give them one golf ball, one Gatorade bottle, one box of tape. Okay, I only gave them one. They had to design their box to hold then however many I said. So in this case, if they had one box of paper clips given to them, but then I told them it had to hold 9 once it was built. Okay, so that way that kept them from stacking all 9 together and then measuring the full width. So they actually had to look at one and then determine how big it would have to be to make 9 in there. So again, you can make it as easy or as hard as you want. Maybe you want to give them all 9 and say, hey, I want you to build me a box that will hold this. But you know what I tell them a lot is if you're in a business and they want something to hold, 24 of it, they're not going to stand there with 24 cans and put them on top of each other and then measure it out. Somebody's designing that more than likely by using a computer design and then using only one bottle. Okay, here's another one again, a really fun geometry. Most of these shapes you will have seen in textbooks. And I have kids who find them very hard to visualize sometimes what the book is showing them that their shape is. And so what I had my students do then one year was they had to actually design, take and use somewhat the values that were given and to make that shape. Okay. Now, according to what it was given in, we may have had to tweak, if it said centimeters or millimeters, and we're like, okay, that's too small. We might have said, okay, let's do it in, centimeters or something. Anyway, but it did work very well. And the kids really enjoyed that activity. This one was, again, a height one, kind of like the bottle rocket one. We just went outside and they had to find the height of a bunch of different things around. So this was the height of the tree and then the height of the building on there. And then again, they had their tape measures and there. You can see this guy has a clinometer in his hand. You can make your own. It looks like she's got her meter stick down here. So she's actually measuring how far it is from the base of the tree. Okay. So we actually did you see our building back here, and the kids actually had to do a full 3D model of the building. And so they had to do perimeter area, height, again. So in this one here, let's see, they're standing right over here, okay? So when you're looking back at this picture, here's where the kids is, here's this peak, okay, and there it is. So obviously, if you comparison, a little bit higher. So what they had to do was they had to design the building, and then they were given a challenge, and it said that the building had to grow, and so where would they put 4 extra classrooms? So this group, the building actually ended here. They chose to put their 4 extra classrooms, 2 on each side, and make a courtyard. Okay. This is another example of that same building. Again, if you're looking at it where the kids are at right now, they would be standing over here on this far side over here is where they're at. There again is that peak that was there. You can't see in the previous, but there are those triangle peaks that are out there. So that gave them also a challenge on there. This one put 2 rooms here and 2 rooms there and extended our hallways that were here. Okay, I allowed them to use any medium that they would like. You see this one? They did sugar cubes. Okay, sugar cubes, kind of interesting there. We also did designing and building their own homes. This was a dollhouse. Again, and really looking at the computations and the measurements and everything that went along with them. Making sure the doors and the windows all fit, so forth. They had to do surface area and volume. And find out exactly, you can see this little, looks like wood flooring and so forth here, and tile here, and how much paint would they need to paint this room. So a lot of